Hi, today we are going to have discussion on one topic. What is it that you will come to know very soon? On screen, you are noticing one irregular shaped body is drawn and it is rigid body. Whenever we say rigid body, we know that it cannot deform whatever may be the forces acting on it. But rigid body is ideal term, it does not exist in reality. What we have in reality is resistant body. Resistant body will act as rigid body for the purpose for which it is designed. You can consider seating bench. When you will sit on it, it will not deform because it is designed for that purpose. Or in other words, we can say deformation will be very negligible. Means resistant body will act as rigid body for the purpose which it has to serve. Nowadays, rigid body and resistant body, these words are used interchangeably. Okay, so we are having rigid body of irregular shape, and that rigid body of irregular shape is having mass m. It will also have CG, and there it is. What we have to do is, whatever single rigid body of irregular shape we are having, we have to convert it into two separate point masses. And those two separate point masses should behave in the same manner as that of original rigid body. Our today's topic is two mass statically and dynamically equivalent system. Two mass system will be equivalent to original rigid body only when it will satisfy certain conditions. First condition is summation of masses of two bodies should be equal to mass of original rigid body. Let us say m is mass of rigid body, m1 is mass of one body, and m2 is mass of another body. So the first condition will be m1 plus m2 equal to m. Second condition is CG, that is center of gravity, should lie at the same location as that of original body. So whatever CG2 mass system will have, that CG should be at same location as that of original body. So what is its meaning? We will discuss it, but before that we will focus on this scale. On screen you are noticing scale is shown, and let us say I have to balance it. So how I can balance it on finger? So I can balance it only when I will put finger at CG of scale. So why I can balance it that way? Because whatever moment we will have due to mass which is on left hand side and moment due to mass which is on right hand side, that moment will be same. That's why it is balanced. Now same thing we have to apply for two mass system. So here you can notice through G, one horizontal center line is drawn in original body and another center line is drawn in two mass system joining two masses. So let us say if we are going to hold original body at G, so that center line will remain horizontal. Now same G is going to fall at same location in case of two mass system. So whenever we will hold that two mass system at that G, at that time center line joining two masses should also remain horizontal. So when it is possible? It is possible only when moment due to the mass which is on left hand side will be equal to the moment due to mass which is on right hand side. So here you can notice on screen mass m1 is at distance L1 from CG and mass m2 is at distance L2 from CG. So moment due to mass m1 will be m1 L1 and moment due to mass m2 will be m2 l2. And whenever this moment will be equal, at that time only we can say its CG is going to fall at the same location as that of original body. Next condition which should be satisfied by two mass system is mass moment of inertia of two mass system should be equal to mass moment of inertia of the original rigid body, and that mass moment of inertia is about Cg. Let us say for original rigid body, radius of gyration is k, and as its mass is m, so its mass moment of inertia will be mk square. For two mass system, we are knowing mass m1 is located at distance l1 from Cg and mass m2 is at distance l2 from Cg. So mass moment of inertia for two mass system about Cg will be mass moment of inertia due to mass m1 plus mass moment of inertia due to mass m2. Mass moment of inertia due to m1 will be m1 l1 square, as m1 is located at distance l1 from Cg, and mass moment of inertia due to mass m2 will be m2 l2 square. So mass moment of inertia of two mass system will be m1 l1 square plus m2 l2 square, and it should be equal to mk square. From first condition we are having relation m1 plus m2 equal to m. From second condition we are having relation m1 l1 equal to m2 l2, and from third condition we are having relation m1 l1 square plus m2 l2 square equal to mk square. If only first two conditions are satisfied, then we will have two mass statically equivalent system, and if all three conditions are satisfied, then we will have two mass dynamically equivalent system. Equivalent system means equivalent to original rigid body. From equation 2 we can write relation for m1 as m2 l2 divided by l1. We can put this relation in equation 1, and after mathematical arrangements for m2 we will have relation as m l1 divided by l1 plus l2, and as we are knowing m1 plus m2 is equal to m, for m1 we can write relation m minus m2, and for m1 we will get relation ml2 divided by l1 plus l2. Now here you will notice it is same as lever rule. For m2 we can notice it is equal to total mass multiplied by opposite arm opposite to m2, and arm opposite to m2 is l1, divided by total distance between m1 and m2, and that distance is l1 plus l2. So for m2 we can write total mass multiplied by opposite arm divided by distance between m1 and m2. In the same manner for m1 we can write total mass multiplied by opposite arm. So for m1 opposite arm will be l2 divided by distance between m1 and m2, that is l1 plus l2. Whatever relations we have obtained for m1 and m2, we can put those relations in equation 3, and after mathematical arrangement we will have relation k square equal to l1 l2.